Its call is now being recorded.
Okay. Turn on your camera, please, Syami Al-Futai. Okay. 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 So we do some exercise here. Okay. Number 5, tutorial. This is tutorial session. So you already know UT. What is UT? Unit step. Unit step signal is wait. Hmm. Okay. So the first question is U, meaning that it is unit step. So unit step, this is T, using T. So all of it is continuous signal. Continuous signal. Okay, this is continuous signal. Okay, because using a T. Okay, so first is UT, unit step. So unit step, the signal is something like this. This is signal for unit step. So from this signal, okay, if we wait, I will draw it for you. Okay. Number 5. Number 5, GT 2U 4 tolak T. A. GT 2U. So when we rearrange, you will get negative T plus 4. Rearrange. And then we need to do, which one we need to do first? Irshad. Okay, which one we need to do first? We have this signal. Which one we need to do first? This is shifting. This is reflecting. This is amplitude. Which one we need to do first? Unmute dulu.
Ya
Amplitude, reflection, or we can call it scaling because it is -1, and shifting. Which one we need to do first? Irshad, Zafri. Just tell me which one.
Amplitude kot.
Huh?
Amplitude.
Amplitude. Okay. Amplitude. Irshad said amplitude. What about Faiz? Wan Muhammad Faiz. Okay, which one we need to do first? Which one we need to do first? This is amplitude, scaling, shifting. Which one we need to do first?
Shifting.
Shifting. Okay. Wan Muhammad Faiz, correct. Okay, we need start from belakang dulu. At the back first. We need to start from shifting and then scaling and then amplitude. Number 1, 2, 3. Okay. Okay. Irsyad jangan lupa study Yang ni penting. Yang ni memang ada dalam test. Nak tak nak memang ada juga. Okay. So, we draw first the signal. This is UT signal. 0, the amplitude is 1. This is T. Okay. Now you need to, the signal shift to the left or to the right? Shift to the left or to the right? Hafiz, Muhammad Hafiz. Unmute.
Left.
Okay, left. By how many steps? How many unit?
4 unit.
Okay. So from 0, you need to go to the back to -4. Okay. 4 unit meaning -4. Okay, shift to the left. And then you need to do scaling. Scaling or reflection. We can call it reflection lah. -T. Okay. Okay, so reflection, it's reflect back. Okay. Ni. Is this? What's this? This is UT plus 4 signal. Okay. And then you need to do U -T plus 4. Meaning that you need to reflect the signal. Do reflection. Okay. T. Do reflection. Become ni negatif ni. 4 ni 0. The signal become like this. Okay. Reflect. Okay. And then the amplitude is 1, still 1. And then you must consider the amplitude 2. So the amplitude multiply by 2. Okay. So the final signal is copy, paste. The final signal is with amplitude 2. Tinggi sikit lah. Okay. 2 GT. This is the final signal. GT. GT. Okay, this is the answer. The answer. Okay. And then we do question B. Question B. Very, very easy. Question B. Scaling only. It's scaling. UT. GT. U 2T. Wait, confirm. GT U 2T. Yes. It is scaling. scaling. So the original signal is okay, the original signal is 0, and then you need to scale it. So 0 times 0 divide by 2. 0 divide by 2, 0 lah, 0. So the signal become like this lah. If 1, 2, 3. So everything you need to divide by 2. Divide by 2. Divide by 2. Divide by 2. You will get 1/2, 2/2, 3/2. So the signal, the amplitude is still the same like this. Okay. Only the signal become 1/2, 3/2, 1. And until infinite. Okay. Same. The signal still the same shape of signal. Okay, this is GT signal. Okay. And then C, RAM. Okay, we have RAM signal. RAM signal. We already done this one. RAM signal. Okay. What is RAM signal? Okay, this is RAM signal. The shape of the signal. RAM signal. Okay. So 5 RT plus 1. Mana? Okay. C. Itu 5 plus 1. Okay. So the signal you need to do shifting first. So shift the signal to the left or to the right. It is to the left by 1 step. So the original signal is like this. This one is T. This is RT. This is the original signal. Okay. And then you need to shift the signal. Shift the signal to the left by 1 step. To the left. Okay. So draw again. Draw again. Okay. Shift the signal to the left by 1 step. It become like this. Okay. This is T. This is RT plus 1. Okay. So the signal become like this to the left from 0 to the left. This is -2, -3. 1, 2, 3, 4. Okay. Amplitude here 1. Lepas tu 2. Lepas tu 3. Okay. The signal become like this. And then we already done for this one. And then change the amplitude 5. So every amplitude here, you need to multiply by 5. Multiply by 5. 5, 10, 15. Okay. 20, 25, 30 until infinite. Okay. So draw again. Draw again. This is the GT signal. Okay. Start from 0. And then it becomes like this. The signal. Okay. 5, 10, 15 until infinite. This is -1, this is 0. Okay? Do you get it how to do it? I hope you get it how to do it, okay? Okay, now we go to number D. Okay? D. You need to do scaling and then you need to do the amplitude -3. -3. Okay? So -3. D. GT equal to -3. -3. R. RAM. 2T. Is it right? 2T. Is it right? 2T. -3 2T. Okay. So, okay, the original one, you already have the original signal here. This is the original signal, copy. And then I paste it here. Okay. Okay, this is the original signal. Okay. Okay, and then 2T. 2T, meaning that you need to make it compress. Okay, bahagi. Okay. Okay. So draw again. One, two, three, 4, 5. So the signal become 1/2. 1/2. 1. 3/2. 2. 5/2 until infinite. Okay. And the amplitude, -3, meaning that the amplitude you need to multiply by -3. So this is 1, 2, 3. Okay. Draw again. Okay. 1/3. -3. -3. Reflection. Y-axis. reflection. Okay. So the signal become like this.
Hello?
Yes, is there any question?
Untuk final exam kan, kena buat step by step macam ni ke?
Ya, baru ada markah.
Total berapa
So
markah?
you get,
Total berapa markah?
sebab dia senang aja. This one only, wait 1 marks, 2 marks, 3 marks. Something like that. 1 mark, 2 marks, 3 marks. Because it is very simple question. If you know how to do it, actually it's easy. Easy peasy. Okay? So negative 3, negative 3. Okay, negative 1/3. And then we have negative 2/3. And then we have negative 1. Okay. Ni 1/2, 1, 3/2, 2, 5/2. Okay. The signal is like this. Okay.
Doktor.
Yeah.
Untuk 3R tu kan dia dekat part CY kan tu kan?
Yeah.
Dia kena bahagi ke 3 tu?
3R. Sekejap Mana? Dekat part C? Yang ni ke? Dah bahagi dah. Okay.
Bukan kalau-
Previously is
kalau kena
1.
darab.
Macam mana?
Bukan kalau dia luar kurungan, tak CY kena darab ke?
Aku tak faham macam mana. Kalau kurungan.
Ada dia punya ni, scaling untuk bila dia
Ni,
keluar pada
ni.
Ha, tu kan scaling dekat R tu. Kan Pak CY kena darab. Macam soalan sebelum ni, dia darab dengan 5. Yang ni pun sepatutnya bukan kena
Dia
darab
macam
Oh, sorry. Darab negatif. Oh, darab. Sorry.
5A doktor.
Sini. Darab negatif 3. Not not divide by 3. It's multiply. Bagus. Pay attention. Okay. Betul lah tu. Multiply, okay? Multiply by negative 3 because it is amplitude. Only the scaling je. Vice versa. Okay? Okay, now we go to question number impulse. This is impulse. Okay, impulse is very easy. GT 2 impulse T plus 3. GT ABCD. GT 2 impulse T plus 3. Betul kan? 2 impulse T plus 3. Negatif 4 impulse 2 T. F. Okay, now what is impulse? Impulse is, the signal is like this. Okay, like this. So for CT signal, this is the original impulse. This is original impulse. So I just copy this original impulse, copy, paste. Okay. Okay, this is the original impulse. You need to do shifting first. Shift to the left by 3 units. So from 0 become -3. From 0 become -3.
Doktor.
Ya.
Tadi time saya buka mic tadi, time saya cakap tadi, dia kena block terus. Saya tak boleh buka kamera, tak apa tu. Dia add as viewer. Check pun tak boleh.
Mana ada? Syafiq. Aku je saya nampak je ni.
Azamuddin tadi.
Mana saya tersetting lain kot. Sorry ni. Sekejap. Nama dia ada Muhammad tak?
Muhammad Azamuddin tu.
Muhammad Alamuddin. Sekejap. MU
Ya, tu.
Mana dia? Dia terkeluar ke apa?
Dia
Ada
apa
tak?
tu? Dia jadi viewer tu,
sekejap.
saya try keluar balik, masuk jadi sama agak.
Sana. Ada 2 orang ni, Zahirul. Mana tidak ada ini? Make a contributor. Contributor ni.
Dia, kalau saya masuk balik, dia tulis view only je tu. Saya check pun tak boleh.
Okay, saya.
Boleh tak? Dah setting ni? Contributor.
Boleh tak tu?
Ada tak? Boleh dah?
Boleh.
Okay.
Check tu.
Okay. So for impulse and then -3. T. Okay. Amplitude still 1. T plus 3. Okay. And then modify the amplitude. The signal. Just copy the signal. Copy. Paste. The signal you must, the amplitude you must multiply by 2. So this is GT signal. Okay, this is the final signal. GT. You already done the shifting and also the amplitude. Okay, now next. Okay, first you need to do something with this question. You need to expand impulse to T minus 2. Okay, do the shifting first and then scaling and then amplitude. Okay, I just copy the original signal. This is the original signal. Copy. Paste. Okay, this is the original signal. PT. And then we need to do shifting. Shift to the right. Shift to the right by 2 units. Okay, to the right. Paste. Shift to the right by 2 units. 1, 2. Okay, this is impulse T minus 2. Okay, and then you need to do scaling. Okay, scaling bahagi meaning that divide by 2. So this signal, you need to divide by 2. So it become 1. Okay, become 1. Okay. Okay. And then amplitude times -4. Meaning amplitude dia reflection times -4. Times -4 become -4. Okay. This. Okay, this is the final one, GT. Okay. So I hope all of you understand how to do it. Okay. Okay, next we go to the next subchapter.
Doktor,
Ya je.
apa tu dekat setiap soalan tu kan, yang kena
Ni.
ada infinity tu kan, kena tulis juga nanti dalam exam.
Yang mana?
Soalan macam soalan A, B, C, D need have to write the infinity dekat
Have to
setiap
write the infinity. Yang ni ke? Ni.
ujung-ujung dia tu.
Yang ni ke?
Macam infinity plus infinity.
Betul. It's better you write the positive and negative infinity. This is negative infinity. This is positive infinity. This is negative infinity. So negative infinity. Okay? Negative infinity. Positive infinity. Ini positive infinity. Okay? Okay, next subchapter. Okay, so we're gonna learn previously we learned about the signals, and then this one is about the what is system. Okay, this from this figure, this is signal and this is the system, more to device. Okay. Okay, a system can be viewed as interconnection of operation that transfer from input signal to output signal. So we have here system. This is system. This is input signal. This is output signal. So the system is here. The symbol we use is H. But that is just the symbol. If I want to put M formula T, it also can. Okay, it is just the symbol. So this one is for because of T, it is CT, continuous time. Because of N here, it is DT. Okay. Okay. YT is impulse response of the CT system. Okay. This one is already explained. YN is for discrete signal. Okay. Real life example of system. Okay. This is the example of system. Previously, signals. So for example, in automatic speaker recognition system. Okay. This is automatic speaker recognition system. The system is used to extract information from incoming speech signal for the purpose of recognizing and identifying the speaker. Okay, it is something like oscilloscope. We have input signal and then oscilloscope will generate the signal inside the oscilloscope. So it is system in the oscilloscope. So in communication system, the system will transport information, okay, information contained in the message over a communication channel and deliver the information to the destination. Okay, this is for example, this is input signal and then we use transmitter to transmit the signal, hantar signal to the channel. And then receiver will receive the signal. And then this is the output message of the signal. Okay. So from this, okay, block diagram, we combine, become system. Okay, input is the message signal, output is the message signal. Output signal is the estimate of message signal. Okay, this is the system. Okay, so we have how many types? 4 types of block diagrams. Okay, so we go to the first one. This is we call interconnection signal. Okay, this is combination of the parallel signal and this signal. Okay, combination of parallel signal and cascade signal. Okay, this is parallel. Parallel and cascade connection. Ni cascade connection. Okay, what is cascade? Okay, cascade is G1 and G2. Okay, it's something like series connection. Okay, how to know the output? How to know the output? Output is equal to G1 times G2 times input. Okay, for parallel interconnection, it's parallel lah. Okay, how to know the output? So G1 times X plus G2 times X. G1 times X plus G2 times X. This is plus sign referring to this. Okay. And then we have feedback interconnection. So feedback interconnection meaning that the output signal here go back to the input. Okay. This is something like car cruise control system. Ni saya pun car cruise ni macam mana? Car cruise. Saya pun tak pasti dia punya function of car cruise control system ni. Tapi macam ni lah. The feedback, the information of the feedback interconnection is the input will go back to the output will go back to input. This is feedback. Okay, and then we learn about the properties of system. This is properties of system. Okay, this is the last one. Okay, properties of the system. Okay, so Friday class, I think we can proceed to chapter 2. Okay, properties of the system. Okay. Okay, first, first properties is stability. Okay, stability. Number one, stability. What is stability? Stability is the system bounded input, bounded output. Be both stable. Be both stable. What is bounded input, bounded output? Input signal is equal to output signal. Input equal to output. Maksudnya no noise. No disturbances at the middle of process in the system. We have system, we have input, we have output. This is system. So in the system, it is no disturbances. Okay. What is input? It's also output. So this is ideal condition that actually it's quite impossible for us to get. In real life, normally disturbance or noise is always in the system. Okay. So stability meaning that it is bounded input, bounded output. Okay. For example, okay, we go to the stable system first. Okay, like this one, voltage. This is just for example, okay. Voltage input. Okay, so voltage input go to voltage output at 1 ohm. Okay, so what is the voltage from input will come out to output. So V input equal to VT. Okay, it is different from this. Okay, voltage here will be stored in the capacitor, unstable system. Voltage input stored in capacitor. So when it is stored, the energy here, the voltage here, different, right? Different from input. It's always stored in the capacitor, and then we can say that input, V input cannot equal to VT because capacitor store energy. Okay, can you get it? Shazrin, can you get it? Okay. Kenapa Syafiq gelap? Okay. Okay, Atira, okay Atira. Okay, nampak mata je, hidung tak nampak dah.
Okay.
Okay. So next. Okay, memory, previously stable system. And then the second one is memory system. Memory and memoryless. Okay. What is memory? This is very, very important. You can see in tutorial, okay, this is tutorial. Okay, determine whether the system, you need to determine whether the system memoryless, time invariant, linear, causal, or stable. We already learned about stable. And then now about memory. Okay, memory. So what is memory? Memory. It is depends on the past or future. Ke belakang atau ke hadapan. Okay, memory means depends on the past or the future. It's memory. It store the memory. So past and future. What is memoryless? Memoryless is only depends on the present value. Okay, masa sekarang. Okay, now. Memoryless now. Okay. It cannot store memory, the past memory and the future memory. Okay. So it is called memoryless. Okay. Hmm. Ni apa? Untuk memory. Okay. This is the example for memory system. Okay. Memory system is something like, okay, the signal store, the input signal, this is input signal, store energy here. Energy store, so the memory of the previous energy is stored here, store. Okay. So it is memory system. This one, memoryless. So what is input? It is output. And then it's it don't have any memory from the previous signal that flow through the resistor here. So it is memoryless system. What input is what output. So don't have any memory of the previous or future. So it is memoryless. Okay. And then number 3. Okay, this is example memory and memoryless system. Okay. Below is the moving average system described by the input-output relation. Does it has memory or not? Okay. For question 1. 1/3 xn. Xn tolak 1, xn minus 2. So, n minus 1 meaning it store memory. Okay. Previous memory. It store previous memory. N minus 1. So, xn is memory. Memoryless. Memory. Okay. So, so in this system we have three function: memoryless, memory, memory, because of the -1 here and -2. Okay, but the dominant. Okay, we must consider if we have system like this, we must consider memory. Okay, memory signal. Okay, compared to memoryless, we can just remove memoryless. It is actually memory system. It has memory, so the value of output signal time depends on the present and to past value. Ni past value. Present is xt, xn. xn. Past value is x, n minus 1, and x, n minus 2. Okay. It is memoryless. It is memoryless because the value of output yn depends only present value. So this one is memoryless system. B, x n times x n. So n does not have n plus 1, n plus 2. So it is n single. So it is memoryless. Atira mana Atira? Tiba-tiba tutup kamera ni. Nurain? Letih dah, tak boleh masuk dah. Ha? Okay. So, do you have any question regarding this memory and memoryless system? Okay. Okay, next causality. Okay, this is number 3. Okay. You must study this one, okay? Causality. Okay, what is causality? A system is said to be causal. Okay, causal system. Normally, student will write casual, not casual. It's causal. Okay, causal system. Okay, if the present value of the this is present value of the output signal depends only on the present or past. Okay, causal depends on the present or past value. Okay. But memory depends on the past and future. Memoryless depends on present. Okay. Causal. And then we have non-causal. Non-causal depends on the future. Okay. Future value of the input signal. Okay. So we have YT output lah. YT output, XT input. So this is the example of non-causal system. Signal, input signal, future. Ni ke depan. Is ke depan apa? In front of the output signal. Okay. Okay, this signal in front of the output signal. So this is future. So this is non-causal. But for causal system, the input signal is past. This is for example. Okay. Macam lambat sikit. Lagging. Kan? Okay. This one is leading. Ke depan. This is lagging. Input dia. This is input lagging. Output move forward. Kan? Ke depan. So this one is the past. Ni past. So this is example of non-causal and causal. So we already learned stable, causal, memoryless. Okay. Okay. Causal and non-causal system. This is example. Okay. Causal and non-causal system. Okay, I put the notes here. Copy. Okay. So this system have future. N+1 is future, okay? Future, and then we have present. We have past. Okay. So this system is causal or non-causal? We have all three signals. So we must consider non-causal, even though we have future signal here. Even though we have present and past. Okay. Present and past ni kan depends based on the causal. But because of one of these signal is future, we need consider it is non-causal. So non-causal is dominant. Dia dominant. Dia utama. Okay. Utama. Kalau tadi previously memory is the main, utama. Okay. Okay. So causality meaning that required system to capable operating in real time. Pada masa tersebut, real time. Okay. And then we have inevitability. Okay. Nak rehatlah kejap. Okay.